Okay, on this video, I'll show a couple of different components that I have, and we'll get some measurements for each one so that we can create a symbol and a footprint in EasyEda. So this first board, this is like a low voltage to 5 volt inverter. All it does is produce 5 volts. I left this one together because it came as a panel of printed circuit boards. I broke one of the rows off, and this is the individual printed circuit board. So you can see that the parts are on the top and the bottom. Now we're going to put it in the board this way with the inductor up. And notice the placement or the spacing on these pins right here. So basically it's the same as 0.1 pitch header. This is a TO 230 package. You see that it's the same as that one. So this is very easy to make this footprint. What we'll do on this part is the symbol will be a little rectangle with 3 connections. You can see VN, V out, and the center one is ground. They didn't label that. It's labeled on the back side. Well, can't focus that far. There it is, ground. So V out, VN, and ground. V out is square. So over here we notice that V out is square. So typically the square pad is pad number 1. So we want to make it like a 1, 2, 3 from bottom to top. And that's all there is to this one. So what we'll do is we'll get some measurements with the caliper, and let's see if I can do this with one hand. So that's, like 0.402. Let me get a better. 407. So we'd probably call that like 0.45, something like that. We don't want to make it too tight, too close. We want to be able to see the silk screen around the part when it's in place. So maybe even a 0.5. And then I notice it's not square, so it's 0.42 that way. So I guess a 0.5 by 0.5 would be okay. It leaves a little bit of room there. So that's going to be an easy one right there. That's just a square with 3 connections to it. This is a push button, a momentary push button. You'll notice it's got 2 wires coming out, and it's square. Okay, so if we just get a measurement of one side, 243, so we could call that point. I hate to be too big, but how about 0.275? That's pretty close. Yeah, 275. So we'll make it square with 275, and these are 0.2 inches apart. The connections I can't do with one hand, but they're 0.2 inches apart, so we just have to space the pads appropriately. I noticed earlier that the wire coming out of this thing is very small. Let me get another reading on that. It's like 13 thousandths. So if we call it like 18 thousandths, that's the hole diameter in the pad. So you'll probably notice that when you create the footprint, you drop a pad in there, and it comes in at the default pad diameter and the default pad hole size. So we want to just create the footprint first, and then we can go back later and update the dimensions of it. Okay, so there's 2 parts, and what I'll do is I'll make a list. I'll write out a list, and I'll take a picture of that, and I'll add it somewhere in the back end of the video, so you'll have those measurements. Here's another connector that I found. It's very tiny. It's like it's a wire connector for printed circuit boards. So this has 2, 4, 4.69 has 9 terminals on it, and goes through the board, so it's through hole. I'm pretty sure this is a 0.1 inch on the pitch here. Could be wrong about that. 0.1. Let me just manually adjust this here. Some of these connectors are 0.1, which is ideal. Yeah, it looks like it's 0.1. It really does. What I like to do is get the breadboard and see how it matches up to the breadboard. So I'm just going to grab one of those real quick. Got a breadboard laying around. Let's see if it'll plug into it. If it will, and it does, it's 100 mils between the pins. Okay, so I like to use a breadboard. Breadboard's 0.1 inches between the holes here. So if it plugs into a breadboard, I can use standard dimensions on that. So on this part, on the connector, it's going to be really easy. It's just like a long rectangle, and I can show 9 connections to it, and that's it. Couldn't be much simpler than that. Here's another connector. This is the type where you push down the little orange tab, and it locks the wire in from the top, so you don't have to use a screwdriver. It's a little strange. It's got a lot of pins down there. It turns out that these 2 pins, like from top to bottom there, are connected together. So it's just a way to anchor it down, because you are going to push a lot on this and move it around. So this has what, 2, 4, 6, 8, 10, 12. It's got 12 connection points, but 24 pads. So on that one, we'll want to get the spacing and see how it matches up to a breadboard. So let's try to plug this into a breadboard and see if it goes in. And it does. So once again, the 0.1 inch pitch between the connections, and we'd want to measure that connection dimension there, the wire itself. Make sure what kind of a hole we need on the pad. This is the last one that I have. It's a 2-part connector. The top part snaps off. The bottom part with the terminals gets soldered into the board. This one has 2, 4, 6, 8, 10, has 10 connection points. It's kind of a large, it's going to be a larger diameter hole for the pad. If you compare that against something like this, you can see the wire is going to be much larger. So for sure on this one, we want to measure the conductor size coming down off of it so that we can get the right hole. Okay, so lastly, got a lot of parts here. Lastly, this is a DC to DC voltage booster. This comes in with 5 volts off the micro USB and would come out here with anything up to about 24 volts or so. So I can adjust it with this potentiometer and it produces a higher voltage. These also snap apart. I left them together just so you can see that they make these boards like by the thousands and then snap them apart for individual sale. So there's one board right there. On this one, we need to get the dimension between the holes so we can space it correctly. And also notice that we have VN on this side, on the left side, but the input voltage really comes in through the USB connector. But we're gonna show a hole there so we can solder like a header pin to these things, a single header pin, and use that to attach it to the board. So we'll show 4 connection points, but we're really only going to wire things to the output side over here. Okay, so let me generate a list of dimensions, and I'll get a photo of that and upload it as an attachment to the back end of this video.